Alright, today we'll create one Red Hat virtual machine where we'll be installing SQL Server. That is, Red Hat is a Linux instance virtual machine where we'll be installing SQL Server. Let's look at the agenda for today. First step is to create Red Hat virtual machine. So let's begin with this. We'll be creating the entire architecture straight from the scratch. That is, even if you have like little knowledge about it, you can straight away follow this tutorial. So I've already logged in to the Azure portal. This time we won't be creating the virtual machine using this interface. Instead, we'll be using the Cloud Shell, which is in the upper right and almost corner in the center. Next, we'll be using Bash. Let's select Bash. We'll select no storage account. Let's choose one subscription and click on apply. So it's requesting the Cloud Shell. I have the commands ready here. So let me explain you what are the steps required to create the virtual machine. So I have named the Red Hat first, then we need to replace the resource group name, right? So let's first browse or duplicate this tab maybe, and let's find out our resource group name because we need to substitute it in the command. Let's open resource group. We have this number. Let's copy and paste this here. Next, if you look, we have the username. This is our username and one password. This is a password. Please keep the password safely because as a database administrator, you need to keep this as a secret. Then we have the image. And then we have since we'll be doing SSH, we have put this, and next is the size of the virtual machine. So we'll be using standard B2S. If you have done the hands-on for the first part, we have created everything like from the portal, but this time we'll be running the commands. Let's copy this thing and let's try to run. We'll close this because we already have noted the resource group. So let's press enter and check whether like it creates. Okay, we are beginning. It's giving considering security these things, right? So it's somewhat is creating. Let's wait for, yeah, it's, see, it shows running, right? Looks good to us. So meanwhile, I'll duplicate this tab because I know one virtual machine will be getting created on the back end, and we need to check the virtual machine once created. So if you look at the next step for the agenda, here we have next we need to configure the SQL Server. So this is getting created. Next will be to create the SQL Server. If you look at the architecture diagram as well, we have this Red Hat virtual machine which is residing in the resource group. As mentioned in the command, we have pasted the resource group name here. So that's what the architecture diagram also depicts. Next are the steps for the SQL Server, right? So let's check it out. What's the progress? All right, our virtual machine is created. How do we know? Because just by looking at this, and we got one public IP address. This will be need because let me open and show you what happened in the backend. If you look, since we have triggered the command, it creates one Red Hat server virtual machine, and it's having the public IP address. Just note this public IP address. It should match with this one. Is it matching? Yes, absolutely it's matching. So let's copy this IP address because we'll be needing it in the steps it's mentioned. Note this IP address because we need it to SSH into the VM, right? Because in order to install SQL Server, first we need to SSH. So let's remove the space. So this looks good. SSH, this is the username, right? If you look here, username is a Red Hat admin. So the command goes SSH username at the rate of public IP address. So let's now copy and try to SSH into the VM. We'll close this window for now because we don't need it anymore. Let's paste this command, hit enter. Yes, we are successfully able to SSH. Now we need to enter the password. So password we have already set up, like this one is our password. I'll type it manually. Please keep it as secret as a database administrator. For this demo, I'm showing this to you because unless I show you, you won't be able to know the exact step. So let me type the password. So yeah, we are successfully in. The password is accepted now. Let's check the next step. Next is the command to install SQL Server package. I have already done the homework for you to explain what the command does. So I'm just copy pasting these things. Let's go back to the portal, paste it. Yep, this one is done. Now let's go back once again. Next is the command to install the SQL Server. So sudo yum install. This is a very classic command if you're already familiar about Linux, right? Let's fire this command. So this might take a bit to install. Till then, let's copy paste the next command. Next command is the configuring a SQL Server and specifying the edition. So this is one of the important steps. Let's copy and wait till the SQL Server gets installed. Alright, this is complete. So let's fire our next command, this one. So we need to mention one edition. Let's type edition 1 and hit enter. Next it will ask for to accept the license and terms. Again, administrator password is required. So let's give the password and hit enter. Again it's asking for password for confirmation. Let's type the same password. Our password is accepted. It's configuring the SQL Server. Let's wait for a while. Alright, it's done. SQL Server is now starting its mentioned. Setup is successfully completed. Let's continue with the next command. Next command is to check whether SQL Server is running or not. Since we got the message, if we look, that SQL Server is completed successfully, we need to check whether it's running because it says now starting, right? Let's use the systemctl command. It's a classic command to check. If we look here, it shows running. So we are good for now. SQL Server is up and running. Now next we need to download Microsoft Server tools for the repo config file. I'll copy and again paste in the Cloud Shell and hit enter. Looks good to me. Now we need to install the SQL Server command line tools. This is essential, right? Let's go ahead and paste this thing. So this tutorial is more about the commands. Like in the backend we need to type yes. In the Windows it's like click of a button, but in Linux we need to fire the command. It says complete. Now next will be to add the environmental path variables. Let's copy and paste this thing. This looks good to me. Now let's fire this command here. Let's copy. P is the after P, if you look, it is the password basically within single quotation mark. So let's run this. Alright, we are good. It shows 1. It means no error. If you got the error, I have already done my homework. You can have a look at this. It will be available for diamond members and above, the entire file. Since we are good, now we should be creating one database. Try to create one database probably because in the architecture diagram, if you look, we are done with the SQL Server installing. Now is the time for the database creation, right? That is our step 3. We are done with step 1 and 2. Step 3 is the next. So let's copy paste this. This is a basic SQL command, create database, then the database name. So our database name will be Cloud Guru Amit in a nutshell. Let's copy and paste this thing, hit enter. Then we need to type go. Just note, we generally semicolon that works, but here in Linux generally go is the command. So this looks good because if we check the numbering from 1 to 2, then again it return 1. It means it is accepted. So our next step will be to verify whether this Cloud Guru Amit database is created or not. So we'll be using one simple statement, select statement. Let's fire this command and check whether our database got created or not. Yes, if we look here, database ID, that is our database, is displayed, Cloud Guru Amit. So we are good. If we look at the steps or the agenda, we are done with 1, 2 and 3. Now next step will be to create basically the table, because our table will reside inside a database, right? So we are done with the database. Now next step or the last step will be to create one table. So we are good. Let's use the command. The problem with Linux is sometimes that it will take only a single line, so we need to copy paste one by one. So still let's try. I know it takes one line at a time. See, use Cloud Guru Amit, so it took just the one line. I'll similarly copy paste line by line, so we need a bit of patience. while using Linux, right? And we need to be careful not to miss the commas and all, otherwise there will be a syntax error. I think is something wrong. No. Employee ID, primary key looks good. There is a space though, but shouldn't matter. Copy, then paste. It's all about copy and paste this time. Let's paste it. Next type go. So change context to database Cloud Guru Amit. This looks good. So let's check whether our table got created or not by firing one simple select star from the table name. We have created the table name as employee. Here if we look, the name is employee, right? So select star from employee is basically should be technically the blank table, right? So let's type go and check. Yeah, this is the blank table, right? There is no data. We have just created the structure of the table like employee ID, employee name, employee salary. So these three columns are there. So we are good. No records because we haven't inserted anything. So this looks good from the tutorial point of view because we have created one table. We are almost done with everything. If you look at the architecture diagram straight from the beginning, so we have used the portal, we have created the VM using the commands inside the resource group, we have configured SQL Server, created database and created one table as well. So this concludes this tutorial. I hope you found this tutorial helpful. Alright, let's tackle this question. We'll first look at option A. A says Azure Table Storage. We can't query the data. If you look at the keyword, that is store and query, we cannot query the data using Azure Table Storage as required by the question. Hence, we'll reject option A. Now let's move to option B. B says Azure Event Grid. Azure Event Grid cannot store nor query the data. Again, incorrect choice. Let's look at option C and D together. C says Azure Cosmos DB SQL API. D says Azure Time Series Insights. Using Azure Event Grid and Azure Time Series Insights, we can both store as well as query the data, which satisfies the requirement of the question. Therefore, these are the correct answer. If we look at the official documentation for Azure Cosmos DB, it's mentioned catalog data usage scenarios involves storing and querying. Just note, storing and querying a set of attributes for entities such as IoT device registries, right? So that's what is required. We'll lock option C and D as the correct answer. Alrighty, let's look at this question. We'll first look at option A. A says Azure Logic Apps Integration Account. Azure Logic Apps Integration Account is an integration service, as the name suggests. If you look, integration here with visual flows with if then else statement. It cannot be used to import data from on-premises to blob storage as required by the question. Hence, incorrect choice. Let's move to option B. B says Azure Import Export Job. Azure Import Export Job service allows physical transfer of large data sets from on-premises to Azure Blob Storage using physical drives such as hard disk. This can be one of the potential answer because the question is looking for two, right? Let's park this. We'll move to option C. C says Azure Data Factory. Data Factory can be used to import data. Again, that is what is required. We'll keep this aside as well. Let's move to option D. D says Azure Analysis Service on-prem data gateway. Azure Batch account cannot be used to import or export data from on-premises to Azure. Again, incorrect choice. Let's lock option B and C as the correct answer. Let's bring the heat to the snow. We have another question and we have done the hands-on for it, right? We have uploaded images from our computer, and this is also unstructured data, video files if you look. So you might be already guessing the answer. So let's dive one by one. We'll first look at option A. A says Azure Files. Azure Files is not optimized for large video files. Hence incorrect. Let's move to option B. B says Azure Data Lake Storage Gen 2. Azure Data Lake Storage Gen 2 is not the best fit for serving video files directly to users due to its focus on analytics workload. Well, we check this option as well. Let's move to option C. C says Azure Blob Storage. Azure Blob Storage is specifically designed for unstructured data. We have uploaded, you might have seen in the storage account, I think part 2, where we have uploaded unstructured data, so making it optimal for video files as well. So Azure Blob can be the potential answer. Let's park this. We'll move to option D. D says Azure SQL Database. Azure SQL Database is not designed for storing large binary files like the videos. SQL Database, we know, is best suited for structured data and queries. This is incorrect. Quick tip for the exam: whenever you see keywords like videos, images or audio files, then think about Azure Blob Storage. If we look at the official documentation, it's mentioned Azure Storage is optimized for storing massive amounts of unstructured data such as text or binary data. Blob Storage is ideal for streaming video and audio. There are also images as well, so you can have a read where Blob Storage is best suited. In the interest of time, we'll lock option C as the correct answer. Alright, we got some scenario here. If we read the requirements, there are certain SLA, dynamic scaling, reserve capacity, this kind of requirement. So we got to choose an answer based on this. We'll first look at option B and C. Option B and C cannot meet the requirement of database varying usage patterns, hence we'll reject these two first. Now between option A and D, we got to choose a better option. Since elastic pull can provide better reserved capacity, therefore this looks good when compared to Azure SQL Database Serverless. Therefore we'll reject option D on the basis of reserved capacity and keep option A. If you look at the official documentation for elastic pulls, it's mentioned Azure Database SQL Database elastic pulls are simple, cost-effective solution for managing and scaling multiple databases with varying and unpredictable usage demands. We'll lock option A as the correct answer. Okay, let's first look at option A and D. These two options, if you look, doesn't allow server-side transactions across database as required by the question. Therefore, we'll reject option A and D. Now let's focus on option B and C. Between B and C, we got to choose a better option. Option B, if we look, uses Azure SQL Managed Instance, which involves minimal administrative effort as compared to option C, that is two databases on the same SQL Server instance on Azure VM. So on the basis of that, we'll keep option B because option B is better in terms of administrative effort, and reject option C for the timing and lock at it as the correct answer. If you want the PDF version of this course along with the hands-on files, then please enroll in Diamond membership or above. Then please connect an inbox on LinkedIn at the rate of Cloud Guru Amit or Instagram at the rate of Amit Physique. I'll be glad to help you out with the PDF and hands-on file access.